Newton's in a good mood. He's bouncing up and down on the trampoline. He doesn't say why he comes back down because he knows the answer, the gravitational force. How did Newton find this answer? While watching the sky, he got curious and asked questions. How do the planets move? How does the moon orbit the Earth? He observed the sky, took notes, and made calculations to find answers to those questions. He compared the information he collected. He was neither the first nor the last person to ask those questions, but he drew an important conclusion. Newton discovered that there exists a force of attraction between all objects in the universe. He called it the gravitational force. He claimed that most events in the universe, such as the planets orbiting the sun, falling back to the ground when we jump, walking, running, and sitting, occurred due to this force. However, years later, Newton's discovery fell short of explaining the depths of the universe. This idea needed to be further developed. Do you know who showed up? Einstein. It's Einstein's turn on the trampoline. As Einstein bounces, he stretches the trampoline downward and forms a hole. The animals around him fall into this hole too. Do celestial bodies have such an effect on space? Einstein began to reflect on this question. What else is going on in the universe? He imagined such a universe that he revolutionized science. He argued that mass bends the space around it, just like the hole that he formed while jumping on the trampoline. The book on your desk, your cat, your bike, the earth, the moon, and stars, all of them bend space around it. Which bends space more? Of course, the one with the greatest mass. For example, the Earth bends space more because it has greater mass than the moon. As a result of this bending, the moon falls towards the Earth and orbits it. All matter in the universe has an effect on each other, and this is how celestial bodies balance each other. There are other scientists having fun in the park. Sliding down a slide, feeling your hair stand up when sliding down a slide, swinging on a swing, playing on a seesaw, talking, using a magnet to pull an object, pushing something, seeing, hearing, thinking, laughing, and breathing. What can all these have in common? You can give many answers such as park, game, living thing, human, motion, the earth, and atom. We want to give the answer that you all may not think of. Here comes electricity and magnetism. In other words, electromagnetism. What is it? Let us explain. An atom, which is the smallest unit of matter, has electrically charged particles. The force acting between charged particles is called the electromagnetic force. For example, when you touch a swing, the atoms in your fingertips interact with the atoms in the swing. This message is sent as electrical signals to the brain, and this is how you feel the swing. The electromagnetic force governs all of the process. It plays a major role in how magnets work. This is how we explain why the opposite poles attract each other, but two like poles repel one another. For years, electricity and magnetism were thought of as separate phenomena. Hans Christian Ørsted discovered that electricity and magnetism are closely related. Experiments of Faraday and Maxwell's equations provided a better understanding of the electromagnetic force. Scientists proved that the electromagnetic force, which has a very long name, affects everything in the universe. Now let us introduce you to a force that will surprise you even more. For this, we need to go to the nucleus of the atom. But first, let's remember that unlike charges attract each other, like charges repel each other. Protons in the nucleus of an atom would normally repel each other. However, they stick together because a strong force acts on them. This force is called the strong nuclear force. This is also a force called the weak nuclear force. However, don't let the name deceive you. It can change one type of particle into another. For example, If you turn a proton into a neutron, such a process occurs inside the core of the sun and results in a release of energy. This energy is essential for life on Earth. The gravitational force, the electromagnetic force, the strong and weak nuclear force. What is their use? The four fundamental forces can explain every event in our universe. That's why these forces are called fundamental. It's important for engineers to understand these forces. They need to take the laws of nature into account when developing a product or experimenting. The fundamental forces are one of them. Launching vehicles into space, connecting one end of the world to the other using the internet, developing drugs, being able to store a large amount of data in a tiny chip. These technologies have been developed thanks to the work of scientists who are curious about nature and the universe. That's why it's important to study basic sciences such as mathematics, physics, chemistry, biology, and astronomy.